Hello everyone, you are welcome to another segment of our class. So today in chemistry, we want to take a look at some important questions from the Department of Chemistry, College of Education, Zaria. So this very particular question is a practical chemistry question, which we are going to solve together presently as far as this tutorial video is concerned. So the question goes as follows. Consider the following equation and answer the questions that follow. 1 mole of permanganate iron plus 5 moles of oxalate iron plus 16 moles of hydrogen protons gives us 2 moles of manganese 2 iron plus 1 mole of water plus 1 mole of carbon dioxide gas. Roman 1 says, copy the equation and put in the missing numbers to make the equation balanced. Roman 2, which of the chemical species is oxidized and which is reduced? In this case, you have, let's say this is 1A Roman 1. So 1 mole of permanganate iron react with 16 moles of hydrogen proton to give us 2 moles of manganese 2 iron plus 1 mole of water. In this case, this is a redox reaction, and we can say that it is an oxidation reaction. Question 1A Roman 1, we have 1 mole of permanganate iron reacting with 16 moles of hydrogen proton to give us 2 moles of manganese 2 iron plus 1 mole of water. So in this case, the equation is not balanced. So we have to balance the equation. Okay. So how do we balance the equation? Take a look at the number of charges and the number of atoms if they are balanced here. Now we have 1 mole here of manganese atom. We have 1 mole of manganese atom here. 2 moles, sorry. So what do? You add 2 here to see if it will balance. Then you have plus 16 moles of hydrogen proton, which gives us 2 moles of manganese 2, okay, plus water. Now our manganese ion is balanced, but oxygen and hydrogen atoms are not balanced. By the reactant side we have 8 oxygen atoms, while by the product side we have only 1. So here we have 16 hydrogen, here we have only 2. So in order to balance this, we need to add we have 2 here, and then 2 plus, then plus 8 moles of water. Then let's take a look at our charges. Now, if you take a look at our charges here we have total of -2 plus 16, okay? While here we have plus 4, so it's not balanced at all. So the total here -2 plus 16 will give us plus 14, and then we have plus 4 here. So which means there is need for us to balance by adding an electron. So to do that, we need to add 10 electrons to this side. Okay, so we are going to have 2 MnO4 minus plus 16 hydrogen proton, which gives us plus 10 moles of electrons, which we have 2 moles of manganese 2 iron plus 8 moles of water here. So in this case, if we go by adding -10 here, which is as a result of this, so plus minus will give us minus, then this 10 electron we add here. The reason why we are adding the electron here is because the electron has to be gained, okay, which is a reduction reaction. So gaining of electron is done by this side of our redox reaction, because gaining of electron simply refers to what? Reduction process. Are we together? So that is why we add 10 here. So in this case, you get to realize minus 10 plus 14 will give us minus 10 plus 14. What do we have here? So we have okay. We have minus, okay, we have plus 4. Here we have plus 4. So you see, by this side we have plus 4. By this side we also have what? Plus 4. So you get to realize that the equation is balanced. Then, taking a look at the other side of the equation, which is oxidation reaction, we have 5 moles of oxalate ion giving us 1 mole of what? Carbon dioxide. So we have 5 moles of oxalate ion, okay, giving us 1 mole of carbon dioxide gas. Now, this particular reaction, as I told you, is oxidation, which involves losing of what? Electron. Now, in order to balance this, we have 5C2O4 2 minus, giving us, to balance this, we need to add 10 CO2 here, so that you get to realize that our oxygen is going to be 20 here, is going to be 20 here, carbon is going to be 10 here, carbon is going to be 10 here. Then, plus what? Look at the total charge here is minus 10. So definitely we are going to add 10 electron here, so that our total charge here can also be minus 10. Okay, you understand? So in this regard, our equation is balanced. So we need to write down the overall reaction. Okay, so the overall reaction, this will cancel this. So we have 2 moles of permanganate ion plus 16 moles of hydrogen proton, okay, plus 5 moles of oxalate ion gives us 2 moles of manganese ion plus 8 moles of water, okay, plus what? 10 moles of CO2 gas. So the equation is balanced. Are we together? So in this case, going to question Roman 2, which says which of the species is reduced and which of the species is oxidized. Now the species that is reduced is the permanganate ion, while the species that is oxidized is the oxalate ion. Remember, permanganate ion is a strong oxidizing agent which can undergo reduction. Okay, so in this case, in the presence of an acid, it serves as a strong oxidizing agent. That is why you see that this proton is present, indicating that the reaction is taking place in an acidic medium. Are we together? So watch out and stand out for the next question that we are going to be taking a look at, which serves as the continuation of this very particular question. So have a nice time till I come your way next time. Bye bye.